In this section, we will have an overview of the Analysis Services architecture for SQL Server 2012. It is essential to understand the main pillars of analysis services. At a high level, it supports reporting and data mining functionality for business intelligence. In SQL Server 2012, it comes in 3 modes. Power Pivot for personal business intelligence, Tabular Model for team-focused business intelligence, and Multidimensional Mode for corporate-wide business intelligence. Why are there 3 nodes of analysis services? In order to meet different business needs, analysis services modes differ in terms of operational context, storage architecture, and memory architecture. Analysis services allows businesses to have fast access to their data, using a wide variety of well-known reporting technologies such as reporting services and Excel. Here, we are interested in 2 types of analysis services, multidimensional mode and tabular models. The multidimensional mode uses OLAP technology, which is disk-based. OLAP stands for Online Analytical Processing. OLAP is essentially a metadata structure that facilitates a way of describing data through a process known as dimensional modeling. Essentially, business users can look at the data from different descriptions, known as dimensions. Tabular models are in-memory databases and analysis services. Using state-of-the-art compression algorithms and multi-threaded query processor, the technology delivers fast access to data by reporting clients such as Microsoft Excel and Microsoft Power View. In the tabular model in analysis services, we store data by using the X-Velocity engine, which is an in-memory columnar database. Instead of considering the row of the table as the main unit of storage, it considers a column as the main unit of storage. It stores data for every column distinctly, at very fast retrieval, and stores data in a very highly compressed way. Since OLAP uses disk-based storage, it is important to reduce the storage footprint for efficiency. This efficiency comes from reducing redundant relationships between dimension members, thereby normalizing dimension storage. The focus must always be on the different type of model to meet a specific business user need. Both technologies are very advanced, and they are created that way in order to meet specific business requirements. In this section, we will answer the question how dimensional modeling concepts are translated into a SQL Server 2012 Analysis Services cube. What is a cube? A cube is a metadata structure which allows users to analyze data by segmenting data into a collection of dimensions and measures. Here is the SQL Server Data Tools for Analysis Services, and this is the browser method of viewing the cube data. A measure is also known as a fact. This is simply a number, for example, a sales figure. A measure is simply numeric data. For example, in the SQL Server Data Tools, we see the measures on the left-hand side. If we choose Reseller Sales Amount and drag it to the main pane, then we can see the value of this measure. A dimension is a way of describing data. This is an entity on which a business user will want to perform analysis, such as geography or customer. Therefore, if we look for geography and look for country and drag it to the right-hand side, we can see our data is described by different countries. Attributes can be described as containers of dimension members. They define the dimension space and allow attributes to be sliced and grouped in order to produce results. Typically, attributes have one-to-many relationships, and they are all implicitly related to the key. Here we have sliced by the attribute country. We can see these on the left-hand side too. Hierarchies are collections of attributes which are organized into levels. Hierarchies facilitate the navigation path through dimensional space. For example, if we remove country and put in the geography hierarchy, then we can see country, state province, city, and postal code. We can also see the cell, which is the very lowest level of the cube, represented here in the reseller sales amount. To summarize, we have looked at the vocabulary of dimensional modelling and how it is translated into Analysis Services 2012. We can see the key terms are cube, measure, dimension, attribute, and hierarchy. When was the last time you delivered a report only to hear "nice job, now run it again by quarter, by month, or by week"? By connecting Excel to a cube, you can empower your end users to make use of self-service business intelligence and create all of these variations by themselves. Further, since the data is located in one place, then it is closer to the single version of the truth that businesses aspire to. Here is an example of an Excel chart here, which retrieves data from an Analysis Services cube. To connect to a cube, we simply go to Data tab, and here we have From Other Sources, and we select the option From Analysis Services. Our server name here goes in the first selection. Our server name is Sapphire, and here are the login details. There are two different types of authentication. Windows authentication is the default and the most common method, which means that the user's login and password are sent down to Analysis Services for verification. The second option is the Secure Store service, and it means that the user and associated credentials are stored and encrypted in the Secure Store database. We will use Windows authentication and press Next. From the drop-down list, we select the Analysis Services database where our cube is stored, and we will select the AdventureWorks cube. Here we are able to give our connection a file name. This might be uploaded to SharePoint, for example, which means that the friendly name is particularly important. When we click on Finish, it asks us if we would like to create a pivot table report, or a chart, or both. We will create a pivot table, and we will do it in a new worksheet. So what we have here on the right-hand side is our list of measures and of dimensions. The empty pivot table is on the left-hand side. So, for example, we could select reseller amount here as a sales amount. We could then choose a hierarchy, such as geography. When we do this, we have sliced our cube. To summarize, we have connected to a cube using Excel in order to obtain the data from one source only, and this is a key business benefit. It is also very simple for users to browse a cube for the information they need and format it how they require. Tasks such as backing up, restoring, and synchronizing your models are vital to both multidimensional and tabular models. How is it possible to conduct these activities on multidimensional and tabular models in Analysis Services? Here, we will look at how SQL Server Management Studio can be used to manage both multidimensional and tabular models. Before we look at the management tasks, how can we determine the server mode of the instance? To do this, we note the icon next to the instance. We use Object Explorer and connect to it using Management Studio. We can see here the instance has a very small blue cube next to the tabular instance. This is how we know it is a tabular instance of Analysis Services. Underneath, we see that this icon is actually small and yellow, and this means that it is a multi-dimensional version of Analysis Services. We can do a number of things with both models, including backing up, restoring, and processing. To do this in Analysis Services Multidimensional, we right-click on the project's name. And this gives us a number of options, including processing, backing up, and restoring the database. So, for example, if we choose to back up, we select the appropriate option, and then the wizard appears here. Similarly, for the tabular model, we have to right-click on the model name, and this gives us a number of options, such as backing up or restoring the database. So again, if we choose backing up, we see here that we have a very similar option that we were given to the multidimensional model. It is possible to use SQL Server Management Studio to execute queries against the models too. With respect to the tabular model, it is possible to execute DAX queries from the MDX query window, as we can see here. We see our tabular model name here, and from this we can see our drop-down cubes, and we are running this against the Internet Sales model. So when we execute this query, we see our results in the results pane at the bottom. If we need help to run queries or to write them, we can use the Analysis Services templates here, which we obtain by going to View and then Template Explorer. To summarize, we can use SQL Server Management Studio for both multidimensional and tabular models, for conducting management activities and running queries. In the case where you've been tasked to create multidimensional and tabular model projects, how do you know where to begin? In this section, we will have an introduction to the SQL Server Data Tools, which allows us to create and edit Analysis Services projects. This applies to both multidimensional and tabular projects. Here is an example of a multidimensional model project. On the right-hand side, we can see the Solution Explorer here. When we zoom in, we see all of the files. These are necessary for the solution. We can see details about the individual entities by double-clicking on them, and then we go to the Properties window down the bottom. This gives us much more fine-grained detail about all of the elements of the solution, and here we have an example for the cube. SQL Server Data Tools works by allowing us to create a model, which is then sent down to Analysis Services. The first stage in the process is to build the model, and we do this by clicking on the project, right-clicking and choosing Build. This generates the underlying XML files which underpin the model that we're looking at. The Deploy stage sends the XML files as a series of instructions to Analysis Services, and we can then see the cube as part of our Management Studio environment. So when we go to Management Studio, we can connect to Analysis Services and we can view the cube. So here on the left-hand side, we see databases, And this is how the cube looks when we look at it in Management Studio. You can see the cube here. Here are our measure groups, and we can see how these are set up in terms of partitions on the aggregation designs. If we like, we can script the objects created here, and we do this by using the deployment wizard. So when we go to All Programs, SQL Server 2012, and then go to Analysis Services, we can use the deployment wizard. And what this will do is it will create an XMLE file which we could give to our database administrator so that he could deploy the cube to the production server. To summarize, SQL Server Data Tools allows us to create and edit analysis services projects and allows us to deploy those projects to servers. If we don't have access to the server, we can generate scripts which DBAs can use in order to deploy projects to analysis services databases. In this section, we will look at what constitutes a tabular model. If you wanted to build a model which had your information in different places, how would you create a model like this? The new tabular model is designed for solving this type of problem. Essentially, tabular models arrange data into related tables. It supports self-service business intelligence by providing accessible data modeling. In 2012, it is possible to create tabular models in analysis services. The structure is based on tables, rows, and columns. The tabular models are best used when you want to import data from disparate sources and combine it in one cohesive model. Tabular models are often used for speed of model creation and delivery of the data. Here, we will see how the data is imported to the model. Here is the model in diagram view. You can change it to grid view by selecting Grid down the bottom right-hand side of the pane. To import data, we simply go to Model, and then we choose the selection Import from Data Source. There are plenty of data sources here, including SQL Server, Access, Teradata, Oracle, and Excel. In our example, we will use SQL Server. Server name. Here, in our example, it is called Sapphire. And when we go down to the database name list, we found our sample database here called Master Data. Now, there are two different types of authentication. One is Windows authentication, where the user's Windows, logon, and password are used to allow analysis services to connect to the data source in order to import data. Alternatively, we could use the service account. This option specifies the model use the security credentials associated with analysis services instance that manages the model. We then click Next, and it offers us the opportunity to choose from a list of tables. We will choose the bottom table here and click Finish. At this point, the data is imported into our model. To summarize, the tabular model is best suited to environments with less complex queries, which mean that the data can be delivered more quickly. For example, here we could use Excel in order to browse the tabular model. We can see the data has been imported into the table very simply. To summarise, the tabular model is best suited to environments with less complex queries, which means that the model can be delivered more quickly. Once the model is deployed, we can access the data using Excel. We could also access the data using Power View as well, for example. To summarise, the tabular model is best suited to environments with less complex queries. The data can be returned quickly to the client due to the X-velocity in-memory engine. If you were required to describe tabular modelling to one of your team members, what are the key glossary terms you need when describing tabular model? A model is a representation of the data. Here is an example of the tabular model in SQL Server 2012 Data Tools. In tabular modelling, the data is formulated into tables. This is a very familiar method of representing data. Relationships exist between tables. On their own, the tables may not tell us very much. Associated together, the tables tell a story. These tables hold data for a fictional bike sales company called AdventureWorks. You have tables for customer data, sales data, products data, and even a calendar. Together, these tables tell a story about the sales data. The tables are joined together using key fields. Here the key fields are the customer key, which are uniquely representing the rows of data in the customer table. It's possible for us to see the tables in more detail. We do this by going to the grid, which we can see at the bottom right-hand side. By clicking on the grid view, we see immediately that it looks much more familiar to us, since it looks much more like Excel. It's also similar to Excel in terms of the formula that are used in order to conduct calculations. For example, when we look at profit before sale, what we have is a very small formula which takes the sales amount column and then subtracts the total product cost column from it. This gives us a very simple calculation of profit. When we look at profit per sale, this is known as a calculated column. This is in contrast with the calculated measure, which we can see at the bottom here. This is a very small measure which calculates the freight. It's simply calculated by using a sum, and the calculation itself can be seen in the formula tab at the top. A calculated measure is simply a measure which has additional business logic applied, which is over and above the metrics that are found in the facts table. Here, for example, we can see the Internet total margin, which is the sum of the margin. This is a DAX formula, which is a data access expressions. These are very simple. When we filter this data, for example, by using the drop-down list here, we can see that the value in the measure has changed now. It has been reduced. This is because measures are sensitive to the query and the context in which they are being requested for information. However, despite the filtering, the values in the calculated column do not change. Therefore, calculated measures are context sensitive, whereas calculated columns are not. To summarise, there are a number of key terms which are applicable to tabular models. These include tables, rows, columns, calculated measures. in calculated columns and DAX. How is it possible to turn data into something meaningful to facilitate self-service business intelligence? The data needs to be related in order to provide a meaningful tabular model of the data. In SQL Server data tools, we can use the diagram view in order to graphically explore the relationships within the model. To create a relationship in diagram view, you just need to drag and drop an object from one table to another. For example, we can join the country area data table to the dim geography table by the country name, simply by dragging country name onto English country region name. In the Properties window, we can see the properties of the relationship, such as the primary key column and the foreign key column, at the bottom right-hand side of the window. The solid lines between the tables indicates that the relationship is active. It is possible to mark relationships as inactive. To do this, we right-click on the relationship and we can select the option to mark as inactive. This means that the relationship isn't used by default when DAX relationships are being created. Alternatively, you can click on the Table menu and select Manage Relationships in order to see what relationships exist in the tabular model. It is possible to have multiple relationships between tables. However, it is only possible to have one relationship between tables marked as active at any one point. For example, here we see that the dim dates table is related to order date, due date, and ship date. When we go back to the diagram view, we can see that the inactive lines are denoted with dashed lines. The dates table permits us to use time intelligence functions in DAX. To view the table, we will go back to Grid View and look for dim date. We identify a table as a dates table by going to the Table menu item, choosing Date, and then choosing Mark as Dates Table. To do this, we need a unique key in the date format. In our example, we will keep the relationship active between order date and the dim dates table. To summarize, we use relationships between tables and time intelligence to turn the data into meaningful stories to support self-service business intelligence. How is it possible to meet a business user's request that you create new data from existing columns in your tabular model? We can use DAX formulas in order to extend the tabular model. Here, we will add a new calculated column to the dates table and a measure to the tabular model, both using DAX. In the dates table, we scroll to the far right and we click on the column to add column. In order to let the tabular model know that there is a DAX formula coming, we press the equal sign and we will create a DAX formula that concatenates the year and the quarter information and adds in the letter Q for readability purposes. When we start to type in dim date, we have a drop-down list. For the concatenation to occur, we will add an ampersand sign, followed by quotation marks, with a Q and finally an ampersand again. We will then add in the dim date quarter information. When we press return, this affects our change. We can rename the column by right-clicking it and choosing the option to rename column. We can then type in our preferred name and then we press the enter key in order to effect the change. Now we have created our calculated column using DAX. We can create a measure using DAX in the Fact Internet Sales table. We will create a measure that adds up the sales amounts information. Therefore, all of the data in this column will be summed. We will place the measure here for readability purposes. We right-click in the formula bar. We could paste a formula here if we liked, but we will actually type in the formula from scratch. We press the equal sign, then we type in sum. The column name we are looking for is Fact Internet Sales, and we are looking for sales amount. We press the closing brackets and we press return. We can see the properties of our measure here. We can rename it to sum of sales amount, and we can also change the type to currency, which is better. To summarize, we can use DAX in order to create new columns and measures in the tabular model. A business user asks you to create a ready-made calculation in a tabular model. How do you know whether to create a measure or a calculated column? Measures and calculated columns are both created using DAX and are accessible from reporting clients such as Power View and Excel. A measure can be defined as a dynamic calculation that's created at design time. When the user displays data from the tabular model, they may use filters which apply a context to the data. Measures are created using the measure grid in SQL Server Data Tools, which is found at the bottom of the table here. In order to see the measure grid, we go to the Table menu item and select Show Measure Grid. We can create measures by using the formula bar at the top here. Alternatively, we can create a measure by clicking on a whole column and selecting the Auto Sum feature here. Measures can use calculated columns and native columns. On the other hand, calculations are defined at the row level. When we go to the dim dates table, we have some examples of calculations here. We can see that the year, quarter, and year month columns are calculated columns, and the value is stored in the database. In the date year month column, for example, we have concatenated the year and the month information by converting the month number to a string and then prefixing it with the year. The values are not impacted by filtering the data. We can see this when we look in Excel. On the left-hand side here, we have our calculated column, and on the right-hand side, we have our sales total product cost measure. If we filter the data, we can see that the measure changes, but the calculated column does not. So, for example, if we choose France, we can see that the row labels have changed the same because that's a calculated column, but the measure is sensitive to the context of the filter that's been selected, so the values change here. Note that calculated columns are not supported from relational data sources in direct query mode. They are only available in cached mode. Measures are supported in cached mode and in direct query mode, where they're converted to set-based operations. To summarize, whether you create a calculated column or a measure depends on the relevant business requirements. How is it possible to implement business rules so that the users do not need to repeat work? Using calculated columns, we can use DAX formula to implement business rules so that the users do not need to repeat the implementation of business rules in the presentation layer. Calculated columns have their values stored inside the tabular database for each row of data. This means it is very fast. Here is a customized DAX time intelligence example. Sometimes businesses will want to compare non-standard time windows, such as 13-month periods. To cater for this business scenario, we can create a series of DAX columns that will band the rows of data according to different time periods. In other words, it will be possible to slice the data to display 13-month periods. Firstly, we need a way of sorting the data so that it will appear correctly in bands. We can do this by adding a new calculated column which contains a synthetic sequence number that will increment by 1 for every new month from the earliest month until the latest month. This calculated column is called month order, and the DAX for this formula shows that we can exclude data that are not in the future, which refers to the first part of the if statement. Then we look for the minimum order year and month and multiply it by 12 in order to create a key. We then add a month number to it in order to give each month a unique identifier which increments from the earliest sales order month until the most recent. We can then create another calculated column that calculates the band that each row belongs in. It builds on the previous column, which was called month order. Here we can see that we are simply labeling the rows dependent on the value in month order. We can edit and view the calculation. If we go to the right-hand side here, we can see a small properties window. We can rename and delete our calculated column by clicking on it and then right-clicking, and we can see a number of options, including the ability to rename the column. However, it's best to decide on the name of the calculated column at early stages, otherwise you will need to change the DAX formula which depends on it. To summarise, it's possible to implement business rules so that users do not need to repeat work. How is it possible to implement business rules in data that allow for users to flexibly slice and dice the data? Here we will create measures that filter data by restricting it to sales amounts that took place in the last 13 months. This can be further filtered by country. Measures are calculations which look at the context of the data, rather than calculated at the row level. They are responsive to user interaction, such as selecting filters or slicers. They are created at design time using the DAX language. Here we have the measures grid for the table. If you cannot find the measures grid, go to Table and then Show Measure Grid in order to enable it. Firstly, you can create measures by clicking on the column and then selecting your preferred measure from the drop-down list here for the Auto Sum button. The second way to create measures is to use DAX. Here we have entered a formula which looks at the last 13 months of sales. We have the sales amount, which is filtered by the last 13 months. We can double check this calculation using Excel. We will connect as the default user. We can see here, we can choose total sales, and we can use the last 13-month sales as well. We can also filter the data by the year. We will move this to the row labels. then it starts to look better. What we can do now is insert a slicer. We will create some space for the slicer first, and then we go to Insert, Slicer. We will use the existing connection, and then we are going to look for the city names and the country names. We will use country for now. We click OK. We can move it to the left-hand side so it starts to look more like a dashboard. We will double check it's connected. Then we can start to slice, and we can see that the values of the measures change. To summarise, using measures, it is possible to implement business rules and data that allow for users to flexibly slice and dice data. How can you quickly identify how a given business objective is performing against a target? Tabular models permit the implementation of key performance indicators, which allow us to compare an actual value against a target value. A simple example of KPI usage might be to identify whether your sales are on targets for a given month, for example. To create a key performance indicator, also known as a KPI, you use the measure grid for a table to select the measure that evaluates to the KPI's performance. In the tabular model, this is also known as the base value. Then, you use the Key Performance Indicator dialog box to select your target value. This can be a second measure or an absolute value, depending on your business requirement. Finally, you then define the status thresholds that measure the performance between the base and target measures. A simple thing might trip you up. In order to create a KPI, you must first create a measure in the table, which you can then place in the measure grid, which you find at the foot of the table. In order to create a KPI, you need to select the base measure in the measure grid. If you don't do this, then the KPI button will be grayed out. In order to make sure that the Create KPI button isn't grayed out, you need to click on the actual base measure in the measure grid at the foot of the table. When you do this, you can see that the Create KPI button comes back. Once you have done this, you can start to create your KPI by pressing on the Create KPI button, which we can see at the top. Since you clicked on the measure value, the wizard already knows what to use as a base value. Now you can select your target value by selecting one of the options from the drop-down list. In this example, we will use the measure called Target Sales Amount Quota. We can then decide which KPI display we will use. Here, we will use the traffic lights with a symbol in order to help people who are colorblind to identify the status of the KPI. We then select our thresholds and we click OK. To summarize, KPIs help us to quickly identify how a given business objective is performing against a target by using KPIs. How is it possible to reduce unnecessary processing and associated processor load on analysis services servers, while simultaneously ensuring that the data is processed enough in order to meet business requirements? It is possible to use partitioning in order to ensure that the tabular model processing works smarter. Partitioning divides tables up into logical objects. Here in this tabular model, we can see we have two tables. One is for the date, the other is for the fact information. When you create partitions by tables, this allows you to process a subset of the data, rather than the full dataset. The data could then be divided or partitioned according to the rate at which the data needs to be processed. This would save overall processing time and reduce processor load by restricting processing to partitions that had a higher velocity of data change. Then data could be changed less frequently in other tables which are not accessed so often. Therefore, partitioned tables support easier and faster data loading, aging, and archiving. This flexibility supports the developer to support the processor in as much as possible, thereby facilitating fast query responses. Now, whether or not we conduct partitioning depends on the type of the model. This model is a direct query model. This means that the tabular query actually shapes the query when it goes down to the SQL Server relational resource. When we right-click and go to Properties on the project, we can see here that the query mode is Direct Query. It's also the same if when we go to the model file, look at the queries, we can see that Direct Query mode is on. With Direct Query, all queries to the model should only directly access the relational data source to answer queries. This means the partition can never be processed, and we see this when we go to the Partition Manager. You can find it here under Tables. So what we see here is we have potentially two partitions here. However, this one, only one can be marked as Direct Query at any time, which is the Date table in this instance. For this to function as a direct query partition, there should only be a single one, and it would also mean that the partition would never be processed. The reason for this is it would be hard for the tabular model to go back, query a number of different multiple partitions, and then execute those queries and then evaluate them in order to meet the real-time requirements. Direct query is most commonly used for real-time requirements, and using multiple partitions in this case wouldn't be suitable since it may not deliver real-time data. The other options are available to tabular model. We can see there are different types. Here we have query mode. We also have direct query within memory and in memory with direct query. These modes could be used very successfully with partitioning because they would allow for different partitions to be in place, which could be processed differently in terms of the data loading, the aging, and the archiving. This would be useful for different business scenarios. When a model is not deployed, then it's only possible to process the partition using the Partition Manager here. However, if we want to deploy the model, we can then see our tabular model in here, and we can use these in order to process the partitions available to us. When we right-click on the table, we get a Partition Manager. This allows us to process the partitions individually in SQL Server Management Studio. To summarize, it's possible to reduce unnecessary processing by looking at partitions. How can we organize the data in the tabular model in order to improve the user navigation experience? We can improve the user experience by introducing hierarchies. Hierarchies are defined as groups of columns that are arranged in increasing levels of granularity. Here is an example of a table, dim country. We can see that each of the attributes within this table are all stored at the same level of granularity. We can rearrange this so that we can provide increasing levels of granularity via hierarchy. To create a hierarchy, we right-click on the table and then we rename our hierarchy. We will call this Geography Hierarchy. Once we've entered in that text, we press Return. Our hierarchy is created, but it needs some attributes. We will choose Region, and then we will choose Country. Each deeper level of the hierarchy refers to more specific data. We can use hierarchies in the tabular model. It also improves performance, since the data can be stored in association with the hierarchy. We simply drag and drop the columns underneath the hierarchy and release it. We then need to deploy our model, which we do by right-clicking on the project's name, and we click on Deploy. When the model has been deployed successfully, we can click Close, and we can go to the Analyze in Excel button, which we see at the top left-hand side here. We choose our perspective and we click OK. This brings us up Excel 2013. We will use the average for the number here, and then we can see our hierarchy on the right-hand side of the table. When we do this, we can see a table which contains the region names. So here we have Africa, for example. When we click on this, we can see all of the African countries' name appear under the top level Africa, which is the region. This experience is much more easy for users to use. It's something that they understand quite comfortably and can be used quite successfully to help visualize data in tables. This is what's known as a natural hierarchy, which sits well with our understanding of the world. We also have the notion of hierarchies in dates, for example. A second type of hierarchy is an unnatural hierarchy. This is where the data perhaps doesn't sit quite so comfortably with our understanding. To check which tabular model hierarchies are natural and unnatural, we can run this command, and it will produce some results for us. Now this basically gives us information about the tabular model, and we can see in the right-hand side we have a column which tells us whether the hierarchy is natural or unnatural. This is simply a dynamic management view, and it gives us information about the tabular model. It is best to use natural hierarchies. They improve performance. This would improve. If you have an unnatural hierarchy and want to turn it into a natural hierarchy, then you can create a series of calculated columns that concatenate the values together. This will create a one-to-many relationship between the levels, and this will improve the user experience. To summarize, we can organize the data in the tabular model to improve performance and improve the user experience by using hierarchies. How can you transform data to meet the business intelligence requirements of your organization, such as displaying trend information, while still delivering quickly? Data Analysis Expressions, or DAX, is a formula expression language which is used to create calculations in tabular models. If you are familiar with Excel syntax, then you have a head start towards learning DAX. It uses functions and columns in the same way as Excel. DAX is more powerful, however, since it applies the same structure of syntax to measures. DAX allows you to filter data, set up relationships between tables, and conduct aggregation in line with business rules. It means we can do some interesting calculations. Here is an example where we want to compare the sales growth of the products since the product was released. So, if a product was released a year ago, then we want to track its growth over the last 12 months. To do this, we need to work out the earliest date of the sale of the product, which we can see from the following formula, which is called product sales first date. The min part of the formula gives us the earliest sales date in the facts table. We know the date is called product date format. We see it at the right hand side. The filter formula applies a filter to the whole table. This means that earlier is allowed to calculate the value of the previous order date key in the table in order to produce the expected results. We can then calculate the number of months between the start of the product sale to the last recorded sale in the facts table. This is done using the formula called month trend sequence number. We can see a sequence number is ascribed to each month depending on its distance between the start month and the last recorded month. It takes the product date format, which is the order date, and then it works out the difference between that and the year of the first sales date, and multiplies that by 12. Then it works out the month of the original sale, and then subtracts that from the current month, or the last known recorded month. We can then visualize this data using Excel. In this pivot table, based on the underlying tabular model, we can see that the spark line provides us with a small visualization of the data. We can also slice this data using the slicers at the left-hand side. How is it possible to describe data using descriptive statistics within the tabular model? Here is an example of a number of descriptive statistics in Excel. Let's see how we can implement these statistics using the tabular model. We can now look at the SQL Server data tools and view our tabular model. The Data Access Language, or DAX, offers a number of formulae that will help us to conduct descriptive statistical analysis on our data. For example, it is possible to calculate descriptive statistics such as the variance, standard deviation, and so on. The variance and standard deviation are simple measures which allow us to identify how spread out our numbers are. DAX offers a number of different ways to calculate these formulae. For example, it allows us to introduce a correction to allow for situations where we are testing the whole population or just simply a sample. Here we have the calculation of the variance. The var p that we see in the middle actually is a standard built-in DAX formula. If we now look at the standard deviation example, we can see we have std dev p. This actually refers to the standard deviation. The p tells us that the formula is looking at the whole population. If we were simply looking at the sample, then we would just have a standard deviation followed by an S here. We can see our options and how they are available to us here in the drop-down list. All we need to do is select our column. So here we will have fact internet sales, sales amount. We close the bracket, press return, and our measure is calculated for us. So now if we go back to Excel, we can see that by using a measure, the values of the standard deviation, the mean, and the variance will all vary dependent on our selection. To summarize, DAX allows us to calculate descriptive statistics within the tabular model in a way that can be visualized using Excel. How is it possible to use the cached model flexibly in order to provision in-memory data quickly, whilst preserving the movement of the tabular model through the software development lifecycle process? One advantage of the tabular model is that the cached model offers easy and fast access to the data, which is held in memory. People can access it using Excel. To do that, they simply click on the connection link, which they can get from the Data Connections folder within SharePoint. This then opens Excel up automatically, and the user can then navigate the tabular model in order to analyze the data. How does the data get to the source, however? There are a number of different ways to deploy an in-memory tabular model to the SQL Server. The model is initially deployed using the SQL Server data tools. To do this, we need to make sure that the deployment options and deployment server options are configured correctly. To do this, we go to Solution Explorer and we choose Properties, which we can see at the bottom here. We first of all need to make sure that the query mode selected is the correct one for the cached in-memory model. Here, the query mode is in-memory. We also need to identify the server name, the database name, and the cube name. If these differ from the default, this can be specified here. We then deploy the model by right-clicking on the project name and choosing the option to deploy. This provides us with a deployments dialog box. We may have to put in a password to retrieve the data from the source, and then it is deployed to the SQL Server. We can also move models from databases to databases instances simply by backing up and restoring the database. To do this, initially we back up the database by right-clicking on the database name for the tabular model and choosing Backup. This produces a small ABF file. Once the data is backed up, we can restore it to a different server or to an existing server with a different name by right-clicking on Databases and choosing Restore. We then select our backup file and we can rename it here. To summarize, it is possible to use the cache model flexibly in order to provision in-memory data quickly whilst preserving the movement of the model through the software development lifecycle process. The business requirement specifies that the data must be returned to the users in an up-to-date and real-time fashion at all times. How can you make this happen using the tabular model? When we run this query, for example, a very simple select query in SQL Server Management Studio, the data is turned in real time using Management Studio, so when we execute the query, we know that the data is correct and up to date because it simply comes straight from the database table. However, the tabular model works in a much more complex fashion. In the cached tabular model, data is not refreshed even if the source data changes. In order to do that, we deploy the model by right-clicking on the project name. The tabular model must be processed in order to get up-to-date information from the data source. On the other hand, direct query mode utilizes data that is coming from a SQL Server database. It lets the users utilize data directly from the SQL Server source. The data, therefore, is not stored in memory. There are a few benefits to direct query. We know that this is a direct query table because we go to Properties, and we can see the query mode here is direct query. We can see this quite simply. When we look at the model, we can also see direct query mode is set on down here. In order for the model to be direct query, then both of these settings must be set, otherwise the data will be cached. By allowing users to see the real-time data, it means that the tabular model becomes a model over data that might not fit into memory, for example. This means that your data could be quite large. The tabular model shapes the data for presentation to the user. The data itself is up to date, and any changes are immediately seen in the model. There are some limitations, however, in the direct query mode. The model can only be queried using DAX. Therefore, this means that Excel and Performance Point will not work very well, since they issue MDX commands in order to retrieve the data. The model only also supports one connection. So what we see here is that we have a number of menu items which are the same for the cached tabular model. But when we go to Model and we have Import from Data Source, we can see here that we only have Microsoft SQL Server as a source. That's because this tabular model is direct query. It's quite simple because it allows us to import tables directly from SQL Server. This would therefore allow us to have the information that we need in real time. That's why we don't see any data here. To summarise, the business requirement to have real-time, up-to-the-minutes data can be served by the tabular model, as long as it is in direct query mode. Can we still have real-time business data with the tabular model, but ensure that failover will occur if the real-time data store is no longer available? The tabular model comes in two hybrid modes, in which data is stored in the X-Velocity engine cache or retrieved directly from the data store. The two hybrid modes differ in the way in which they are able to answer queries. Hybrid query mode models can answer queries directly from the relational data source using direct query, or use data that is stored in the X-Velocity engine cache. We can see this when we go to Properties. We can see that we have the query mode is direct query at the moment. In order to instigate a hybrid mode, we can choose query mode here. If you want queries to be served by direct query mode only, then you need to select direct query within memory mode. On the other hand, if you want the queries to be primarily served by the X-Velocity engine cache and then failing over to the real-time version of the data, then you need to choose in memory with direct query mode. Then we click OK and we can deploy the model. To do this, we click on Properties, then we right-click. To change a partition to direct query only, then we need to change the partition in the Partition Manager. So if we choose a dimension, we can change partition to a direct query partition in SQL Server Data Tools. We select the table that contains the direct query partition we want to manage. In this example, we will choose Fact Internet Sales. Then we go to Table menu, then Partitions, to launch the Partition Manager. we select the Direct Query partition. This partition is identified by the Direct Query prefix in front of the partition name. We select this partition, and in the Processing option box, we choose Never process this partition, and we click OK. This means that the Direct Query partition is now Direct Query only, and data will never be processed into its cache. You can see now there's no data left. It's all cleared from the workspace database. The transaction that commits a change to the Direct Query only partition drops all of the data for that partition. This may be useful for development purposes. To summarise, we can still have real-time business data with the tabular model and also have failover occurring when the real-time data store is no longer available. What is multidimensional modelling, and when is it best used? Data is vital to any business, but it can only be useful to move the enterprise forward when it is shaped in a form that can be used for analysis. Although there are many different ways in which we can make the data suitable for analysis, one way of organising the data is to use the multidimensional model approach. With this approach, data is seen as a unified entity that has business meaning. In other words, analysis is made more meaningful when the numbers or dimensions are made to be related to one another explicitly. In this chart here, we can see we have a number of ways of describing the data. We have country and we have product line. These are the dimensions in our dimensional model. They are basically ways of describing data. On the chart, we see we have metrics or numbers which are displayed on the chart. These are our facts, and these can be aggregated in order to give us the sum of sales or the sum of profit, for example. The dimensions, when put together, help to describe the numbers in a way that the business can understand and use in order to move the enterprise forward. Multidimensional modelling supports the creation of complex calculations that are in line with business rules. In analysis services, the dimensional model is created using a cube. The numbers or metrics are known as measures, and we can see them here in SQL Server Data Tools on the left-hand side, in the browser grid. We go to Measures, we see them grouped, and these are called measure groups. And we can pick and we can drag any of them to the right-hand side here. This will give us a number of ways of describing the data. So here we have our metric in terms of sales amount, and we describe our data in terms of the dimensions. And all of these items we see here, such as product line, calendar year, and so on, are parts of dimensions, and we can see the dimensions. When we go to the dimension tab here, we have a number of them: dim date, customer, and we have due date, ship date, and we have product as well. These are simply different ways of describing the data. And here's a copy of the date dimension here with the attributes under it. To summarise, multidimensional modelling is useful for moving the enterprise forward, since it shapes the data into meaningful business ways. Often, business users have different requirements regarding when they need to access their cube data. So when we browse this cube, we can see that the number of internet counts are organised by year. So this data is information we could use as a trend, but other users may need real-time information. How can you arrange your cube so that it best meets your users' requirements, whether they be real-time or perhaps longer trended analysis, for example? Analysis Services stores its data into partitions in a number of different ways, depending on the ways in which the users would like to access the data. we can see there is a Partitions tab, which we find under the cube file. When we click on the partitions, we can see if the cube is actually divided up into partitions. So here in AdventureWorks we have 4 partitions. They are all a particular storage type. We can change that by clicking on Storage Settings. So here we have a range of storage settings available to us. On the left-hand side we have Rollup, which is real-time. Analysis Services doesn't read data from the relational database. It only checks that the metadata is consistent. Rollup is useful since it has less storage requirements and is good for large datasets which are not queried very often, such as historical data. The detailed data is stored in the underlying relational database and can therefore handle huge amounts of data. The most common type is MOLAP, in which Analysis Services loads data. Using the data, it builds indexes and aggregations so that the data is shaped in a way that the business users can use in order to create reports. MOLAP requires frequent processing to pull the refreshed data, with latency after processing if there are any changes to the relational database. MOLAP is a mixture of Rollup and MOLAP. Analysis Services performs a metadata check for the Rollup partitioning method and then builds up MOLAP aggregations to serve up business users' data. To summarize, we can use partitioning and partitioning strategy and types in order to meet the user requirements. Rollup is suited to real-time operational requirements, whereas MOLAP is more suited to longer-term analysis. Multidimensional expressions is a query language that users can use in order to return results from OLAP cubes. MDX is also an expression language which has plenty of useful features. Its functions can help us to define calculated members or even build subcubes on the fly. MDX can allow us to apply business logic and use hierarchies, which are very powerful for usability and returning results. This Excel file shows some data which has been extracted using a query, which Excel has created behind the scenes when the user selects from the pivot table. MDX focuses on multidimensional data using constructs called cubes. Cubes have more than 2 dimensions, which are simply ways of describing data in a business way according to known entities, such as product. These dimensions help us to understand the business metrics. These are also known as the facts. In our example, the dimension is the order date dimension, and the metric is sales amount. We can generate the same query using SQL Server Management Studio. To run a query in SQL Server Management Studio, we first of all need to connect to the Analysis Services instance. We can see this here. It is denoted by the green arrow sign just to the left of the cube. Once we have connected to our cube, we simply need to click on the New Query button, and this will produce us the pane that we see in the middle here. And here is our MDX query. We can see that measures sales amount appears on every line. This is then specified as being present in the column that we see down here. These references are called tuples, which are like pointers to the cells or the groups of cells in the cube which the business user required. Groups of tuples identify slices of the cube, which are areas of the cube that the user is interested in. Ordered tuples are often known as sets. A name set can be used to identify a subset of business products, or a collection, such as we have here, of years. To summarise, MDX can be a complex language to learn, but this is the basic structure of generating tuples and connecting to a cube in order to retrieve the data that we're interested in. How is it possible to use MDX in order to make things easier for users to access their data? In this Excel example, we can see that the product models shown are restricted to the top 10 selling models. We can see this feature is part of the pivot table setup. We see it under the products dimension. So if we go to the product dimension and look under sets, we can see there is a set called top 10 product models. How is this created using MDX? To create this in MDX, we need to go to the SQL Server Data Tools. We need to open up the cube file, which we do by double-clicking on the relevant cube in Solution Explorer, which can be found at the right-hand side of the page. This takes us to the cube structure, but we are interested in the Calculations tab, which we can see on the third tab from the left. In order to create a new name set, we right-click on Calculate, and we choose the option to create new name set. Here is the example which we saw earlier in the Excel worksheet. We are interested in the expression, which we see here. This expression is created using MDX. It is using the function topCount, which returns the top number of members dependent on a particular criteria. Here, the formula topCount is measuring the top products models in terms of the sales amount. We can see from the number 10 in the middle, the topCount is looking for the top 10 members. The top 10 members are defined by the top 10 in terms of the sales amount, and it is looking at the top 10 product models. We can also look at the script view by selecting the script icon directly next to the form view. We can see it here, and this shows us the underlying MDX. We can see the topCount function, which is measuring the top products models in terms of the sales amount. We can go back to the form view by clicking the button just directly left to the script view. To see our new name set using MDX, we need to deploy the cube, which we do by right-clicking the product's name and selecting Deploy. To summarize, it's possible to use MDX in order to make things easier for users to access their data more simply in the reporting layer, simply by using MDX. When should you use MDX and when should you use DAX? The answer depends on the data source. Analysis services multidimensional models use MDX. On the other hand, Power Pivot and the tabular models use DAX in order to obtain information. How easy is it to translate MDX to DAX, for example? Let's look at this MDX example. Here we have some information which we can see some of the data is missing. We can also see categories where the data is not available for components and unknown. When we look at the equivalent DAX query, we only see information where data is available. Therefore, the equivalent DAX query does not show the same result. Therefore, we need to be careful when replicating MDX into DAX. Here is another MDX example. Here we can see the data has been split for the year 2007 and also for 2008. We can see categories for products where no data is available. When we try to replicate this in DAX, we use Summarize, and we also use Calculate Table, which provides us with a table of data for us to use in order to obtain the information. Again, we are trying to get the data for 2007 and also for sales 2008. When we execute this query, however, we notice that 2008 information is missing. This is because the Calculate Table part of the DAX statement is filtering the data to the year 2007. This means we cannot see any of the 2008 data. This is referred to as the context of the filter. In order to start with an empty restriction, we can add the product category information in too, using Calculate Table again, add columns, and we also use all as well. This gives us an empty context in which we can see all of the data which is not restricted to certain years. So we have 2007 data, and we also have 2008 as well. We can see this from the result set. Since we have used all, we can also see data for categories. To summarize, when we use MDX for multidimensional cubes and DAX for tabular models and Power Pivot, we need to check our results carefully when translating from MDX to DAX. Dimensions are ways of describing data, such as the geography or the product associated with the data. How is it possible to set up dimensions in analysis servers as cubes? Here we have an example dimension here in the slicer in Excel. In order to set up a dimension in SQL Server analysis services, we must firstly have a table set up in SQL Server. Here we will use the date table as a source for our dimension. When we select the data from the table, we can see that it holds date information here. We import the data into the cube by opening the Data Source view in SQL Server Data Tools. To do this, we right-click in the Data Source view and we select the option to add and remove tables. This generates a small wizard which allows us to import the data and use it for creating a dimension. When the table is contained in the Data Source view, we can then add it as a dimension. To do this, we right-click on the Dimensions folder and we select the option for New Dimension, which we can see here on the right-hand side. So when we select New Dimension, we have a small wizard. We will use the option to select an existing table. The next page shows us tables from the Data Source view. From the drop-down list, we can select our New Dimension table. We need to give the key column and the name column, and then we select Next. We then select the columns we would like to see in the hierarchy, and then we click Finish. We then give our new dimension a name. To proceed, the dimension needs to be specified as part of the cube. To do this, we go to the cube and we go to Dimension Users tab. This shows us the associations between the dimensions and the measure groups. First of all, to add the dimension, we can click on the Add Dimension button here. When our dimension is added on the list, we can associate it with the facts table via the measure groups association here. So we click on the ellipse, and then we're given the opportunity to define the relationship between the dimension and the facts table. Here we have a regular relationship, which simply means that the table is directly associated with the facts table. To summarise, we can set up dimensions in Analysis Services cubes. Here is an example of a dimension. We have the data based in SQL Server, and then we use SQL Server data tools. We use the data source view to import the data. We then add a dimension, and then we associate the dimension with the cube. Can Analysis Services be used to help users produce simple but meaningful charts using easy-to-access calculations? In Excel, here we have the profit calculation. We also have another chart which shows the performance of the top 10 customers in terms of sales. Analysis Services supports a variety of calculation types. One is a very simple calculated member. It extends the data in the cube by shaping the data in accordance with business rules and formulas, thereby helping the data to be interpreted. Here is an example of a calculated member in Analysis Services, which underpins the profit calculation we saw in the Excel workbook. We create calculated members in SQL Server data tools. To do this, on the Calculations tab, we right-click and we select New Calculated Member. We can see this in the menu here. We then give the calculated member a name, and we also type in an expression in MDX. This particular expression takes the sales amount and removes the total product cost from it, leaving the profit. We can then create a named set. A named set is another way of simplifying chart creation for users. It restricts the potential number of members down to a meaningful set. This set, for example, could include the top 10 customer list, as we saw earlier in the Excel workbook. Sets can be dynamic or static. In a dynamic set, the members of the set is constantly updated in response to the user queries. On the other hand, static sets are not resolved repeatedly and aren't dependent on the context of the query. To create a dynamic set, we right-click and we select the option for New Named Set. We give our set a name, and then we assign an MDX expression. This particular MDX expression counts the top performing customers in terms of the sales amount. We then specify whether the set is dynamic or static in this drop-down list here for type. We then deploy our project by right-clicking, choosing Deploy. The users can then see the results of the calculation in Excel or other clients. Is it possible to use Analysis Services to contribute to the performance management of the organisation as a whole? Performance management is the alignment of financial measures. Part of this process involves key performance indicators, which are known as KPIs for short. Analysis Services allows for the creation of key performance indicators, which can be displayed in a variety of ways. Here we have some KPIs displayed using performance point services and shown in SharePoint. KPIs are part of the model of performance known as the balanced scorecard. SQL Server Analysis Services allows you to create KPIs in the multidimensional and in the tabular models. KPIs are defined using SQL Server data tools, which we can see here. To create a KPI, we first of all open the cube. Here we are using the AdventureWorks cube. We have a tab here, which is simply called KPIs, and to create a new KPI, we choose the selection New KPI, which we get when we right-click. Here is an example of a KPI called Channel Revenue. We have a note of the associated measure group here, and we can see the value of the KPI, which is Measures Reseller Sales Amount. That is the actual metric, which is based on an existing measure in the cube. Here we have the goal expression, which is based on the target metric. Here it is an existing measure in the cube, but it could also be an absolute value. The status metric is defined by setting thresholds. This is done either as a percentage or as an actual figure. Here we use a small case statement in order to identify the status. It is using a percentage. Once we've generated the status, we can also work out the trend, which again is uses MDX in order to qualify the trend of the KPI. It is possible to deliver analysis services KPIs using pivot tables in Excel, reporting services, or performance point services. To summarize, analysis services contributes to the performance management of the organization of a whole. It does this by supplying the facility to make KPIs, which can be displayed in a number of interesting ways. How is it possible to use attributes in the cube in order to improve the user experience when looking at the cube? On the left-hand side here, we see a number of attributes which are grouped under the sales territory region hierarchy. What we can see here is a number of actions that we can define. These will be stored in the cube, and that will allow us to make the user experience more easy to navigate. For example, here we have the UK reseller information action. When we look at the reseller sales measure group, what we will see is an if condition that says if the current member is United Kingdom, then it means we will have an additional drill through available to us when we use this particular measure. The drill through will give us reseller information from the reseller dimension, and it will also give us the attributes for sales territory region, country and group from the sales territory dimension. When we have defined our action, we need to deploy it to the analysis services servers. What we have here in the browser is we can see the cube. However, it does not allow us to analyze the data specifically by cells. Instead, it only allows us to analyze the cube via the columns. To see the information properly, what we need to do is analyze it in Excel. So here we have the number of sheets in Excel, and we have a pivot table, which is the exact same as the data that we saw in the SQL Server data tools. We see the reseller sales amount information, which we also see here as well. So when we go back to Excel, what we can do is right-click on the measure. We can right-click on the dimension attribute, and what we see here is there are no actions defined for this particular attribute. When we click on the measure, right-click, we do have a drill through available to us This is the UK reseller information which was defined in the analysis services cube. And we see here the columns that we defined in the action. We see the reseller information from the reseller dimension, and we also see the attributes that we selected from the sales territory dimension, the region, the country. So what we have here is when we look at Excel, we quite simply have available to us the detailed information. This means that the users have a mix of the aggregate information in the pivot table and a breakdown of the information as well. This particular drill through is not available for the other attributes such as southwest and southeast, northwest and northwest. Since we specified it was only available to the United Kingdom, that's all that it's applicable to. Because it's in Excel, we have the ability to use the other filters and features as well. This makes the user experience much more nice and easy to use in Excel. In analysis services, how is it possible to use partitioning as a very powerful and flexible mechanism to improve performance control? Well, partitioning allows us the division of data into logical parts. This allows us to place our data on different locations and manage it differently. Analysis services, by default, creates a single partition for a measure group. Why would you want multiple partitions for a measure group? Here we have an example here of different partitions on a single facts table. These have been divided by year. Using multiple partitions will improve performance, since analysis services can traverse a smaller amount of data in order to obtain the results. Partitions can also be processed and configured flexibly. Before we begin, there are two important things to note. Firstly, the query that creates the partition should be created so that each fact row is only included in one partition. We can see this in the query here. When we zoom in, we receive a warning, which tells us that we run the risk of double counting rows if rows are included in more than one partition. Secondly, we must also be sure we are running the Enterprise Edition of Analysis Services. To double check, we right-click on the project and we go to Properties. In order to create multiple partitions, we need to be running the Enterprise Edition, which is what we are doing here. In order to create a partition, there's a small wizard here called New Partition. We can use that. Alternatively, we can look through the menu too. We can see here that there are a number of windows here which will allow us to find out how we can check the partition. When we double click on the cube, we can go to Cube, and we see there is an option for New Partition as well. We will choose that one. We will click on Next, and we must select a measure group. We will specify a query to restrict the rows. I'm going to delete the default query, and we are going to select a query which uses the year 2005 and less. When we click on Next, we can use the current server interface or the default location, and that's what we will do. When we click Next, we will give it a sensible name, so we'll call it Internet Sales 2005. We will not design aggregations at this point in time. Instead, we will click Finish, and we can see our partition. If we want to see that as part of the data available in the cube, we need to deploy it by right-clicking on the project. To summarize, partitioning is useful for allowing us to manage our data more simply and effectively. it possible to retain different groupings of data in the cube, but analyse it differently according to business need. Here we can see some measures corresponding to different years. Measures are an essential part of the business, since they show overall the performance of the business. In the AdventureWorks example, for example, we can see that it contains measures that are crucial for the performance of the business, such as sales figures and unit price figures. Measure groups are facts data, and they are organised in the SQL Server data tools. Measure groups are collections of measures, if they have the same granularity. Granularity is defined as the way in which the fact data is married to the cube in terms of its size and its complexity and its level. Each measure group can aggregate different data from different levels, so some data could be stored daily, others weekly. If we have different measure groups in the same cube, this means you can analyse the data in different ways. For example, here we have the sales amount for internet sales. When we go to the reseller sales measure group, we see we also have the sales amount, but this time it is for resellers. This helps us to identify the sales amount that refers to specific groups. Measure groups have a number of properties, which we can see on the right-hand side. One particular feature of note is unrelated dimensions, and we can see this on the right-hand side. It tells the cube what to do in the event that the data is retrieved by dimensions that are not used in the fact itself. There are two options. One is possible to ignore the dimensions and the result depends on the other dimensions. Secondly, it is possible that the data is simply considered as missing for the requirement and is not displayed. To create a new measure group, we right-click and we select the option New Measure Group. When we've done that, we select a table here and then we click OK. We do get a warning if following tables are already used by measure groups. When we do this, it very simply comes up with the number of measures which are available in the cube and grouped together. In order to see the measure group, we need to deploy the cube by right-clicking on the project and selecting the option to deploy solution. When we've done that, we can browse the measure group in Excel, for example, which we see on the right-hand side here. Multidimensional expressions, or MDX, is an extremely powerful and flexible language for interrogating cube data structures. How can we use MDX to navigate hierarchies simply and easily? One popular MDX function is children. This returns a set that contains all of the children of a particular member. We can run this query by highlighting it and clicking on the Execute button, which we see over here. Alternatively, the F5 button will achieve the execution of the query. When we execute it, we get the result in the window pane here. However, bikes is identified by this reference, and that's not very readable. We can, however, explicitly identify the reference by using bikes and children here, and that way we know we are looking at bikes. When we click Execute, we get the same results, but this code is much more readable. The children function allows us to see the children of a particular member. The descendants function is similar, but it allows us to see all of the children of the member, right down to the leaf level. This example, we can see we have used bikes and children again. we have simply used descendants. This will give us all of the children for bikes. And here we have more examples here. Now, we can also filter the data by using the filter expression here. When we execute it, we will only get product names where the value exceeds $10,000. We can see this here. So the data is immediately filtered. It only refers to data from the year 2008. Now, one problem with this data is that we can see nulls. In order to get rid of the nulls, we can use non-empty. This will give us a subset of the data which is restricted to the products where the product cost is over $10,000. And we are also hiding all of the null values. So when we run the query this time, we see that the nulls have gone. To summarize, MDX is an extremely flexible language which is powerful. Its complexity is made easier by the fact that the member names are very similar and meaningful to the business terms that are used rather than column names.
Aggregations are a fundamental concept that is core to most business intelligence solutions. Transactions often need a degree of aggregation so that the source, transactional, and operational systems can be made more meaningful to business teams. Further, they are vital for removing pressure from operational source systems. Data can be confusing in its raw format, but aggregations can help us to see how numbers can be more meaningful, for example, by summing them, making averages, or simply counts. Aggregations can help us to see changes over periods of time, or can help us to see information in relation to geographical groups. We can design aggregations along useful axes. Here we have Internet Sales aggregation. These have been created in order to try and make the most of the sales information. To design aggregations, there is a wizard. We can click on the aggregation we'd like to change, and we click on Next. And here we have a number of options that could be included in our aggregation. These could be automatically applied to the cube in order to optimize it. An aggregation is simply a data structure that contains a pre-calculated summary. The smaller than the fact data is based on, so it is expected that aggregation design is an important part of optimizing the performance of the cube. We don't need to aggregate everything, however. In some cases, it may not be sensible to do that. If we click on an attribute and go to the isAggregatable property, we can set it to false, which means it will not be aggregated. For example, it wouldn't make sense to add actual and budgets together to make an all total, since it would not be meaningful to business users. Another way to optimize existing aggregations is to use the usage-based optimization wizard. This uses the history of the queries accessing the cube in order to identify which aggregations would add the most value. We can do this when we generate a wizard. To do this, we need to allow analysis services to query the log. However, it will need to know the log file connection string. To set the log file connection string, we need to go into Analysis Services in Management Studio. We look for our instance name and we select Properties. About halfway down the list, you will find the option for Query Log Connection String. Aggregations are useful for optimizing cubes.
Analysis Services cubes need to be processed so that the data can be refreshed and that others can see the changes. Given that users will see the results of the cube processing, how can we process the cube to meet their needs, as well as make sure that the processing has occurred correctly? In order to process the cube, we simply need to right-click on the cube itself, and this gives us the opportunity to process the cube. When we select the opportunity to process the cube, we are asked if we are sure, and then it takes us through to a window. This will give us plenty of opportunity to process the cube. There are different ways and ends that you might want when you process data in the cube. If you want to fully reprocess a partition, then you need to use Process Full, and you can see that this is the default option here for processing the cube. It deletes partition data, indexes and aggregations. There are other options. For example, the Process Data option allows us to delete partition data, indexes and aggregations. It only loads data into a partition and allows you to organize and schedule processing of the data. This permits a separation of data from the indexes and aggregations, which can be processed at a separate time, when there is less requirement for large amounts of memory on the server. There is a Clear option, which simply deletes partition data, indexes and aggregations. On the other hand, the Process Index option allows us to build partition indexes and aggregations. The Process Add option allows us to incrementally add data to a partition. In other words, it is an update command. If we want, we can see the information that the cube is doing when it processes. So when we go to a new trace, it will ask us first of all where we'd like to save the trace. We would like to save it to a table, and we can save it as part of a table, as part of a database. So we will call this test process. When we run this, we can watch what the cube is doing. When it processes, we can see there is a lot of information which is being generated. If we stop the trace, then it is written to the table, and we can connect to it using Excel. So we could connect to it via Excel using the server name. And then we can connect to our database. We don't need all of these tables, just the ones that we are interested in, so we will connect to our test process table here. And here we can traverse the data a bit more easily, thereby ensuring that processing has occurred correctly. You can also see this from SQL Server Data Tools as well. The process has succeeded, where we can obtain more information by looking at the trace.
Once you've created your Analysis Services cube, then you can deploy the project to Analysis Services, where it will be visible to other users. There are a number of options for deploying your projects to Analysis Services successfully, and we will look at these here. The deployment options are set in the Property Pages dialog box of the project. This can be obtained by right-clicking on the project's name in Solution Explorer. On the left-hand side we see three options. These options are responsible for the total deployment sequence: build, debugging and deployment. The build option varies according to the version of SQL Server that you are using, Standard, Enterprise, Developer or Evaluation Edition. Upon build, if you see an error message that tells you that a particular feature is not supported, then you may need to check that the deployed version of Analysis Services is the same as the version of Analysis Services that you used for your testing. The build process can involve processing the Analysis Services database, which may include a lot of data to be processed. It is possible to configure the project settings so that the database is deployed straight after processing. To do this, we click on the Deployment button on the left-hand side. We can see our options here. We have Full, Do Not Process and also Default. If you want to delay the database process stage because you are developing, then it is possible to select the Do Not Process option. This means the database won't be deployed straight after processing, as it is in the Full option. We can also see underneath the server name and the database name where we want to deploy our cube. We can also see transactional deployment. This indicates whether the Analysis Services deployment script should be treated as a single transaction or not. In practice, processing as a single transaction means that, if the deployment fails, then all of the changes will be rolled back. If transactional deployment is set to false, then the objects are processed independently of each other, and the failure of one object will not necessarily mean the failure of all objects. Once the options are set up, it is possible to deploy the project. We do this by right-clicking on the project's name and selecting Deploy. We click on OK. We right-click on the project and select Deploy. If we see any errors, they are displayed in the window at the bottom right-hand side, and then users can see the contents of the cube by browsing it. Now that we have created our tabular model, how is it possible to use the data in the tabular model to benefit the business users? Here is SharePoint, and we are in the Data Connections folder. Here we have a data connection called AdventureWorks BISM, and what this does is it allows us to connect to our tabular model. When we click on it, we can see we have a number of menu options. The one that we are most interested in is Create Power View Report. It's also possible to use Excel too. So, simply all we need to do is click on that option, and it will generate a new interface for us. And this is where we create our Power View. It's very simple with the normal Office ribbon here, and our dimensions and facts in the tabular model can be found in the right-hand side. It's very simple to use. It's just click and tick. The user does not have to do any real typing or creating formulas. That's all done in the tabular model, and the only thing that users need to do to type is the name when they're saving the file, which they do over here, File and Save As. So, on the right-hand side, to create a very quick report, very simple, we just tick the box that we require based on our tabular model. So what we see here now is a very small table which gives us the country names. We can see here on the right hand side that some of the options are greyed out. That's because the relationships are not supported in the tabular model. Therefore, the users do not even have to worry about creating relationships. Here we have our Fact Internet Sales, and we will select Sales Amount. And that appears here on the right hand side. So that very simply gives us a way of creating a table. But as we know, tables are not the most interesting ways to visualize data. So what we could use is a bar chart. It's very simple to augment the comparison facility of our visual systems. By sorting by sales amount, for example, then we sort by descending as well. And then all we need to do is create a title. And we've created a very simple report in Power View, which will allow the business users to start to understand and visualize their data. In Analysis Services, it is possible to visualize data using key performance indicators, and we can see how they're visualized when we look at KPIs and then select the browser view, which we can see at the top here. When we zoom in on these icons, we can see that they are red, yellow and green. Now these colours are not comfortable for everyone who is colourblind. How is it possible to rectify this situation and produce icons which don't impact people who are colourblind? What we can do, we can close this solution and we can go over to Reporting Services instead and use that in order to visualize our data. So this is Reporting Services in SQL Server Data Tools. Here's a preview of a very small report. And what it does is, it takes the actual value of the income and compares it with the target value and gives you a percentage of the actual versus the target value, which is 226%. Whether it's in target or not is identified by a very small square here, which is coloured blue. How can we do that? When we go to the Design tab, what we can see here is a very small expression. Essentially what it does is it takes the net income value and divides it by the net income goal value. Therefore, we are measuring the actual against the goal value. When we create this very small icon here, all we do is use the letter 0 and we use wingdings. That turns this character into a square. What we can do then is we can change the colour of the square dependent on the value that's found in the expression. So the expression is simply the actual income value divided by the goal value. It's given as a percentage. And what this switch statement does is it identifies the value and then compares it. So if it's less than 75%, the square is coloured red. If it's over 90%, it's coloured blue. We can see here in this example that the very small square is coloured blue. The advantage of this approach is that it's very simple, easy to read, and we are not using colours which may impact people who are colourblind. To summarise, Reporting Services allows a great variety of flexibility around reporting on data using Analysis Services cubes as a source.
How is it possible to use the tabular model as a data source in order to produce visualizations like this in Excel? When we deploy our tabular model, we deploy it to the Analysis Services database. But what we need to do then is to create a connection in SharePoint, which we actually use in Excel. We create the data connection in Excel, and we do this by going to Documents, a new document, and then we create a BISM file. Our BISM file is going to be called Sapphire. And it's on the Sapphire database here. The database that we will be using will be called Model. Now we can see our data source here called Sapphire. And in the drop-down list, we have a number of options. One is to launch Excel, and that's the one that we are interested in here. We will need to open the ODC file using Sapphire and SharePoint, and we will enable it. We can see here that we have our cube, which is model, and this is the name of our tabular model. So when we click OK, we can see here that there is a pivot table appeared, and on the right hand side, here are all of the fields and the dimensions that are available in our tabular model. So all the user needs to do now is to click and tick, and this will give them the information that they are looking for. So, for example, when we go down to the products dimension, we can see that there are a number of different products we can select from. So we can choose English product name, and this will give us all the information about the English product name that we see here. And then of course we can create some metrics associated with this. Here we have products category. And now if we get rid of English products name, it's a bit easier to read now. So now that we have the products category, we can start to add in some metrics. So what we could have here, for example, is internet total margin. And then we can add in the date as well from the date dimension. If we add from calendar, give it to year, put it in column labels. Then if we right click on the blank cells, we can show a 0 for the empty cells. Then if we like, we could create a spark line here using this data and then showing the spark lines in this range here. And here we would have visualized our data using Excel and the tabular model as a data source. How is it possible to use analysis services as a data source in order to visualize our data in Excel? This is SQL Server Data Tools, which is new to SQL Server 2012. And what we see here, Analysis Services Cube Browser, is that we have the ability to analyze data in Excel now. We have a very small Excel button here, just under dimension usage. And we can see that when we browse the cube, and the browse button is over at the right hand side. So when we press this button in Excel, it asks us which perspective we would like to see. There are a number here already contained within the cube, and what we will do is we will choose the AdventureWorks perspective. Excel will now ask us about a security notice. I'm going to enable this data source, since we know that this data source is actually the cube. So what we see here in the right hand side is that we now have the cube's dimensions and metrics available to us. So when we scroll down, we can see we already have customer geography, which we will put in the row labels. We can then choose calendar, and for example, we could choose year and have that as our column labels. Now this in itself just makes a small visualization, but we can make it more appealing by using conditional formatting. So on Grand's Total, we can use the colour scales, for example, or we could use data bars. Here, we will use data bars. We can then change this small table so that it is more aligned with the colours we've chosen. What we can do now is visualise these numbers here, using the same conditional formatting button. When we click on it, we can choose icon sets, then we can choose these symbols down here. Now what that means is that some of the data does not display very well. We could actually hide this information completely. The way that we can do that is to go to the button here, which identifies the data type. We go to More Number Formats. We choose Custom. And what we do then is type in 3 semicolons. And you can see that in the Format Cells dialog box. When we do that, we click OK. And that means that our numbers are no longer displayed. Instead, what we have is a pattern relating to the numbers. What we can then do is switch off the grand tables, on for the rows only, and then our data suddenly appears as if it's much more slimline along the columns. We no longer have the data on the columns here for the totals, but this has been done in order to make the columns here much slimmer. To summarise, we can visualise our analysis services cube data quite well using Excel, helping us to self-service. What data visualization principles underlie Power View? This Power View report is actually looking at a tabular model. We will select country, and we will also select two metrics. So we will select product cost and sales amount. We're only using two countries here. This is known as filtering the data. Normally, people like to engage with the data by using summaries, and then they filter the data, then they like to see the detail. So what we can do is turn this into a bar chart. This allows us to compare the data. So, for example, if you read the works of people like Stephen Pugh, they stress the importance of allowing users to visualize and to compare data. It will help them to understand it better. We will go by sales amount and we'll descend the data. That means we can see quite clearly that the United States is the largest amount of sales amount here and product cost. We can click on sales amount, and that quite simply allows us to see exactly what's going on with the sales amount. It also facilitates comparison. What we can do is add in another table as well, and this will allow more interaction with the data. So if we click outside this visualization and say, for example, we choose product standard cost here, we will also use country again. We can see these are in order we don't expect. So what we will do is swap them, and that looks better. So now, for example, when we filter the data, the two charts will talk to one another. We'll pop this down here, and we will also visualize this data as well by doing a very small chart. We're going to sort the data by the product standard cost. We will do it descending again. So now, for example, if we click on Australia, the United States, what we do get is the charts actually talk to one another. This quite simply facilitates more interaction with the visualization itself. Therefore, there's some interesting visualization principles which lie underneath Power View.